complements and unions of events. Complements, that's pretty much the same thing as saying not. So if you see this A bar, I'm going to say that as A bar, or the complement of A. So to find the probability of the complement of A, it's like finding the probability of A and taking that away from 1. 1 is the highest value you can have for a probability answer. So probability of not A is equal to 1 minus the probability of A. For that to make sense, let's look at this first example. If there's a 30% chance it will rain, what does that mean? Well, to find the probability that it won't or it won't rain, most people would just take 100% minus 30%, which is 70%. Well, that's what that is. That's what this is representing right here. Because this 100% represents 1, and this 30% represents probability that it will rain. So this won't rain is a complement of will rain. Like I said, it's the not portion of it. So it's like 1 minus probability it will rain. Or 1 is the same as 1 with the decimal, the same as 100%. So 100% minus 30% is 70%. So you already do this, you just didn't know, maybe you didn't realize that it has wording involved. Let's look at this example. Consider rolling a single die. Find the probability of not rolling a 3. So you may just want to think about it straight up. 1, 2, 3, 4, 5, 6 are all the ways you can roll a die and what it will land on. So if you want to do it just by thinking about it, how many ways can you not have a 3? Well, there's 1, 2, 3, 4, 5. Have how many total rows? 6. Or you could do it like this. Probability of not a 3 is the same as 1 minus the probability of a 3. See that? And how many ways can you roll a 3? There's exactly one way to roll a 3. So you can write it as 1 minus 1 over 6. And if you know anything about fractions, you know that 1 is the same as 1 over 1. LCD is 6. So you times that by 6, that by 6. You get 6 over 6 minus 1 over 6, which is also 5 over 6. So you have two different ways you can actually approach this problem. It doesn't matter to me how you do it. By the way, in case you're wondering, 1 minus 1 divided by 6, math, enter, enter. Yes, it will do fractions. Now these next few examples involve the other formulas that were given. So I'm going to erase some of this to get it out of my way. Let's erase some more. It's interfering with what I want to say. Okay. We see the words mutually exclusive. What that means is they have nothing in common. So if you remember anything about Venn diagrams, they will look, two circles that look like this. They have no overlap. So these are mutually exclusive. Nothing in common. Now if they are not mutually exclusive, they do have overlap. Venn diagrams can be helpful in a lot of areas in probability. And so, if they are mutually exclusive, and we're finding the union of the two events, and union means or, that means you're going to just find the probability of this A circle and the probability of this B circle. Now, if they are not mutually exclusive, like this one, when you add A, you're adding this whole circle, and I'll show you what I'm talking about. So if I like use a blue, and then if I add the B, what do you notice just then? You notice that there's some overlap there. So when I add the blue, then I add the green, I've added this intersection twice. So that means is, and yes, that does mean intersection, means and. That means that I have to subtract it once. So that's where that comes from. So I don't want to double count, in other words. So that's what that means. Let's do some examples. And you may not want to use the formulas, and sometimes you just have to. So let's say that you're going to randomly select a card from the standard deck of 52. We're going to find the following: a jack or a king. Those have nothing in common at all. So one way you can do it is think about it. How many jacks in a deck of cards? 4. How many kings? 4. So the probability of a jack or a king, you can just do it like this. We got 4 plus 4, which is 8. And just do it 8 over 52 and reduce to 5 by 4. 2 over 13. Now we could do it with the formula also, which is going to be the same thing, by the way. So if I do the probability of a jack or king, and I could actually use the notation, the union. So if I do J or K, what I would do is I do probability of jack plus the probability of king. Let me erase this, just to give me some space. We already know what the answer is, 2 over 13. Just so you can see what the formula does. How many jacks are there? There's 4 out of 52. How many kings? 4 out of 52. And we still get 8 over 52, which still reduces it down to 2 over 13. So, either way you think about it, you get the same answer. In other words, if you want to use the formula strictly, that's fine also. Now, in this example, probability of choosing a queen or a spade. And now this one you have to be careful with. In fact, what I'm going to do is I'm going to list all the queens. We have a queen of diamonds, a queen of hearts, a queen of clubs, and a queen of spades. Now if I list all the spades, we're going to have ace. These are all spades, by the way. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So I'm going to find the probability of choosing a queen or a spade. Have to be, there's one way I can do it. There's 2 ways I can do it. One way is I can just count. How many queens are there? There's 1, 2, 3, 4. 4 queens. And how many spades are there? 13. But notice the queen of spades and this queen of spades I've already counted. So if I already counted it here, that means I have 12 remaining I have to count. Did you catch that? I only get to count it once. So I have 4 there, and then 12, or 4 queens, and then for spades I have 12 other cards that aren't a queen. So that means I have 4 plus 12 over 1252, which is 16 over 52. And then once again, if you haven't noticed, I will divide these by 4 quite a bit. 16 divided by 4 is 4, and 52 divided by 4 is 13. Now, if I want to use the formula, I will do this. And the formula may make it a little bit easier to understand. So, probably choosing a queen or a spade. And since there is a queen of spades, there's some overlap. So that means I'll be finding the probability of a queen, probability of a spade, minus the intersection. Did you catch that? Let me just write that down again. Give us some space. Give me some space. You're smothering me. Probability of a queen or spade is probability of a queen plus probability of a spade minus the intersection of a queen and a spade, or queen of spades, if you want to say it in poker terms. So what's the probability of a queen? Well, there's 4 out of a possible 52 cards. How many spades are there? Well, there's 13 total out of a possible 52. Well, how many queen of spades are there? Well, there's just the 1. So subtract it off. So when you do that, you have 4 plus 13 is 17, and 17 minus 1 is 16 over 52, which still reduces down to 4 over 13. So the formula may be easier. I don't know. It's just your choice. Sometimes it is, sometimes it isn't. Word problem. Okay, when you read this, you'll see that 35% we're concerned with improving cardiovascular fitness. We'll just call it that, fitness. 55% want to lose weight. And that same percent are concerned with either improving their fitness or losing weight. Big word there is or. We want to find the probability that the person concerned with both improving fitness and losing weight. That's what we're trying to find. So what formula do we know that has or and an and in it? And furthermore, if you look at these percentages, if you take the 35 plus 55 plus 70, that's way bigger than 100%. There's some overlap going on here. A lot of overlap. That's what we're actually trying to find, the overlap. So these are not mutually exclusive. And sometimes you can see that with the percentages if you try to add them all up. So let's use F for fitness. And we'll use L for losing weight. And that's all we need. So the formula that we have, which is the very first one of the first formulas provided to you, it's this one. I'm just going to use F and L instead of A and B, in case you're wondering where I'm getting this at. So F union L is equal to the probability of F plus the probability of L minus the union, or the intersection, I mean. Remember, this is an or, and this is an and. So now let's look at what we have. 35% we're concerned with improving fitness. So what that means is that 35% will go there. Now since I want to use a decimal for probability, I'm going to use 0.35. And then for L is losing weight, that's 55%, which is also 0.55 as a decimal. And then we have same percent with either improving or with improving fitness or losing weight. So that's the or, so that percentage goes over here as a decimal. And the and is the unknown. So that's our unknown. So this is a mathematical equation that we're going to solve. So you throw in the numbers and do the work. Try to find what's left over. In this case, this is our variable we're going to solve for. So let's take the 0.70, keep it over there. On the left side, we're going to add these two together. And that's 0.90. 55, 75, 85, 90, yeah. You can always use a calculator if you want to. And this is our big old variable. Now the way I would actually solve this, I would actually add this over and subtract the 0.70, but some people don't like that, so I'm just going to go ahead and subtract the 0.90 from both sides to isolate our variable. And so 0.70 minus 0.90 is not 0.20 because it's a negative. We're taking away more than we have. And this is not the probability of F intersect L, because we can't have a negative probability, because, and we won't, because that comes down in front. And some people need to realize there's a 1 in front of that. So to get this by itself, we'll divide both sides by a -1. And when you do that, the probability of improving fitness and losing weight is 0.20 or 20%. You're better off using decimals just to make sure that everything lines up as far as the probability rules go. And that's it.